welcome to another lesson. This is the last part that we're going to be doing on the gradient and the equation of straight line. So we're going to look at two more questions and then we call it a topic. Now the first question here is a question from the KCSE 2019 and it reads part A. A line L1 passes through the points 3, 3 and 5, 7. Find the equation of the line in the form y is equals to mx plus c. Part B, another line L2 is perpendicular to the line 1 and passes through point minus 2, 3. Find the equation of the line 2 and the x-intercept of line 2. Then part C, determine the point of intersection of the line 1 and line 2. So we start with part A. We have line 1 that is passing through point 3, 3 and point 5, 7. And you need to get the equation of the line. And the first thing is for us to get the gradient of the line, which is given by change in y divided by change in x. In this case, it could be having 7 minus 3 divided by 5 minus 3. And 7 minus 3 is 4, and 5 minus 3 is 2, 4 over 2 is 2. So gradient of this line 1 is 2. Then we want to get the equation of the line. So we take a point like 3, 3 of where the line is passing at the arbitrary point x, y. And of course the gradient is 2, then we say gradient is given by change in y over change in x. So y minus 3 divided by x minus 3 is equals to 2. 2 is the same as 2 over 1 because multiply 1 times y minus 3 is equals to 2 times x minus 3. So y minus 3 is equals to 2 times x, 2x, 2 times minus 3 get minus 6, then y is equals to 2x, take minus 3 on the other side, we have minus 6 plus 3, and then y is equals to 2x minus 3, minus 6 plus 3 is minus 3. So that is the equation of the line 1 in the form y is equals to mx plus c. Y is equals to 2x minus 3. Then part B of the question, you'll be told that another line L2 is perpendicular to the line 1 and it passes through point minus 2, 3. Find the equation of the line 2. So the first thing here is to ask ourselves, what do we know about the perpendicular lines? And of course, we know that the product of the gradient of the perpendicular lines is equals to minus 1. So m1 times m2 is equals to minus 1. So we know the line 1, we have the gradient as 2. So 2 times the gradient of line gives us minus 1 divided by 2 on both sides, and then m2 is going to be equals to minus a half. So that the gradient of the now line 2, gradient of line 2. Now having the gradient, and we have a point where the line is passing, passing minus 2, 3, you can be able to get the equation of that line. We have a arbitrary point x, y, and then the gradient is minus a half. So we have now gradient is given by change in y over change in x, y minus 3 divided by now x minus minus 2 goes to minus a half equals multiply. We have 2 into bracket y minus 3 is equals to now minus 1 to bracket x minus minus 2 is x plus 2 because minus followed by minus is plus. So 2 times y is 2y. 2 times minus 3 minus 6 is equals to minus x minus 2. Then 2 2, y is equals to minus a half x plus 2. That is the form y is equals to mx plus c. And then now we need to answer part B, the x-intercept. So for us to be able to get the x-intercept, we know that the equation is a half x plus 2. To get the x-intercept, we know at x-intercept the value of y is equal to 0. So we just take our equation here. To equate to change or to replace y with 0, because at x-intercept y is 0, so 0 is equals to now minus a half x plus 2, and that one we're going to be having to take this minus half x on this side. We have a half x is equals to 2, and of course multiply by 2 on both sides to remove this half here. X is equals to 4. So that is our x-intercept. X is equals to 4. So x-intercept is x is equals to 4. That is where the line is cutting the x-axis. Let's look at part C. Part C is to get the point of intersection of line 1 and line 2. First thing is to have the equation of line 1. We had it as y is equals to 2x minus 3. And then the equation of line 2 we had is y is equals to minus a half x plus 2. So for us to know the point of intersection of two lines, we just solve the two equations simultaneously. So we have the first one, y is equals to 2x minus 3. The other one is y is equals to minus half x plus 2. So we can equate these two and have them as now 2x minus 3 is equals to now minus a half x plus 2. Because this is the value of y, this is the value of y. So this one should be also be equal to one another. Then we put the right term together. So minus a half, we bring it on this side. We have 2x plus a half x because it was minus. And if also the equal sign is going to be plus, is equals to 2, then minus 3 on the other side is going to be plus 3. Then 2 and a half x equals to 5. 2 and a half is the same as 2 times 2, 4 plus 1, 5 over 2x is equals to 5. We want x, we multiply by 2, 5 on both sides, so that that one can cancel, and that one cancels. We have to x is equals to by 5, 1 by 5, 1, 2. So the value of x is 2. Then y, we can pick the first equation, is given by 2x minus 3. So 2, our x is 2 minus 3. 2 times 2, 4. Minus 3 is equals to 1. So x is 2, y is 1. So the coordinate, because we are to get the point of intersection, should be 2, 1. Now to our last question, it reads, find the equation of a straight line passing through the points 3, 2 and minus 3, 6, giving us in the form x over a plus wherever b is equals to 1, where a and b are constants. Then part B, state the coordinates of a and b at which the line a in a above cross the x-axis and y-axis respectively. Part C, find the actual angle the line in a above makes with the x-axis. And D, using the information in a and b above, find the area of triangle A or B, where O is the origin. Now the first part, we need to get the equation of line in the form x over a plus y over b is equals to 1. And the first thing to get the equation of line, we need to have the gradient. So part A, the line is passing through point 3, 2 and minus 3, 6. We need to get a gradient, which is given by shading y over shading x, where y is now 6 minus 2 divided by minus 3 minus 3. So this is going to be 6 minus 2, you get 4, minus 3 minus 3, you get minus 6. So divided by 2, you're going to get gradient is minus 2 over 3. So that's our gradient of the line. Then we need to get the equation. You can take a point like first one, 3, 2, and a literal point x, y, and of course we have the gradient as minus 2 over 3. So gradient is given by shading y over shading x, then shading y minus 2 over x minus 3 is equals to minus 2 over 3. You cross multiply, you get 3 into bracket y minus 2 is equals to minus 2, and x minus 3. And then 3y minus 3 times 2, 6 is equals to minus 2 times x minus 2x minus 2 times 3, you get plus 6. Then dy is equals to minus 2x plus 6 minus 6, take it to the side, go to plus 6. Then dy will be equals to minus 2x plus 12. Then you write it in the form y is equals to mx plus c. You have divided by v here. We have y is equals to minus 2 over 3x plus 4. Now, we are not going to write an equation in that format, but that is the first step to get the equation in the form y is equals to mx plus c. Now, we want to write the equation in the form x over a plus y over b is equals to 1. And we just need to know that the a and the b, these ones are the x and the y intercept. The a is x-intercept, and then b is the x-intercept. So value of b, we have it, is equals to 4, the y-intercept. So we need to get the value of a, which is now the x-intercept. So to get the value of a, using now having the equation of y form y is equals to mx plus c, we're going to write it here, y is equals to minus 2 over 3x plus 4. Then we we know that at x-intercept, y is equals to 0. So 0 is equals to minus 2 over 3x plus 4. You can take this on this side of the equation side, so we can have now being positive 2 over 3x is equals to 4. We multiply by 3 on both sides, and then we have 2x is equals to 12, then divided by 2, x is equals to 6. And now that is the value of a is equals to 6, meaning now that our equation of this form is going to be x over a, which is 6, plus y over b. Our b, y-intercept is 4, is equals to 1. So that is the answer to part A. Y x over 6 plus y over 4 is equals to 1. Then, part B, you've been told to state the coordinates of A and B at which the line in A above crosses the x and the y axis respectively. So this one, of course, we have the answers with us because if we just have a sketch here, this is the y-axis, this is the x-axis. Then, if this is our line, then y-intercept is that point. So the value of y there is 4, and the x-intercept in this point is at 6. That's where the line is cutting the x-axis. We have been told that. Now, we find this is the coordinate of A and B, which in which the line A above crosses the x and the y axis respectively. Meaning A is now the x intercept and the y So this is our A, this is our B. So to get the coordinates of A and B, we have at A, the x is 6, but we know that, of course, the y is 0 at x-intercept, meaning the A is going to be 6, 0. Then coordinate of B, at y-axis, the values of x is 0. So the values of x is 0, but now y is 4. So those are the coordinates of A and B. Part C of the question says that find the actual angle the line in A above meets with the x-axis. Let me sketch the points. The x-axis, we found that the 6, so that is point A, and then point B here, and this is y-axis, so this is x-axis. Now, how to get that angle? We are basically going to use the our equation of the line, which was in the form y is equals to mx plus c. We had y is equals to minus 2 by 3x plus 4. Then, to get the angle, we know that the angle is given by shade in y over shade in x, and for the trigonometric ratios for the tangent, it is given by tan, theta is given by opposite over adjacent, and in this case, the tangent of an angle is equivalent to the gradient, and our gradient is minus 2 over 3. But in this case, we are going to ignore the minus sign. We take it the absolute value of our gradient. So, because that is the change in, that is the vertical change divided by the horizontal change, which is equivalent to the tangent of the theta. So, our tan theta will be equals to the same as the gradient, which is 2 over 3. But of course, we ignore the minus sign. Then, we need to get the theta, so it's going to be the tan inverse of 2 over 3, and this is going to give you, using the calculator or table, going to be like 3.69 degrees. Lastly, we are required to get the area of the triangle AOB using the information in A and B above, where O is the origin. So this is our A, B, this is our O, the origin. We need to get this area of that triangle. So from here to here, these are 6 units, and from here to here, those are 4 units. So to get the area is going to be very simple. Area of a triangle is given by a half base times height. A half, our base is 6 units, times height is 4 units. So by 2 and by 2, 3 times 2, 3 times 4, we get 12. So the area of the triangle AOB is going to be 12 square units.